Hello, geometry scholars. So this week, before we embark on triangle congruence proofs, we are going to spend today on what I like to call this pre-proofs. And we're going to be doing these problems in Delta Math that are called finding angles. And my goal for today is to help us develop the vocab and problem-solving techniques that are useful for you as you work towards proof level thinking. So the goals are to, one, create a cheat sheet that will help you have all the major proof reasons in one place. And actually, not only do we have these for proofs, but knowing these vocab words will help you on earlier skills. So this is really like built-in review. And then we are going to be starting to think about geometry angle problems by building a sort of step-by-step justification. And what we want to be working towards is using the geometric definitions strategically so that we can create this sort of step-by-step reasoning that justifies, some type of result in geometry. And this result could even be, why does the angle in this diagram equal 50 degrees? And you may not in real life argue about a geometric result. But if you're writing a good quality English paper, if you are making an argument about something, you are going to have to use specific evidence in a logical manner. And geometric proofs really are a concrete example in being able to do this. All right, so I'm going to demonstrate what a Delta Math problem is going to be looking like after today's lesson. And what you're going to notice is you're going to see diagrams, and you're going to be finding different angles in the diagram and then justifying. So what we have here are sort of the steps, and then on this side are the reasons, and the reasons are just concrete definitions from geometry. So we're using definitions from all of our geometry so far. And one of the nice things about Delta Math is that they give you a word bank of possible reasons, but it is your job to know what these mean. And I want to make sure that you have the best opportunity to get good at proofs. So we are going to make a cheat sheet. So please take out a piece of paper or a Google Doc, and we will go through the vocab words. All right, so what I wanted to do here, especially with like the building blocks of geometry, is give you the written definition and then also a picture of what it looks like. So the first thing that we're starting with from Unit 1 are the vertical angles, aka I like to call them the chopstick angles. And what we can notice here, let's say, we have a diagram. I'll call this A, B, C, and maybe I'll call this D and E. And I could say that angle ABC and angle DBE are congruent because they are vertical angles. So two angles that are directly across from each other that share only the vertex. So only that point B is what those two angles share. Linear pair and linear triples. So anytime I have like a straight line that is beneath maybe two angles or three angles, that is a linear pair. And on some of the more difficult examples today, you may have a situation where there are actually 3 angles instead. And these angles add to 180. Both of these examples do. And technically speaking, this is called a linear triple. Congruent angles, these are angles that have the same measure. So if I had that this angle was 45 degrees, and then this angle was 45 degrees, maybe I'll call this ABC and DEF. And I could say that the measure of angle ABC is equal to the measure of angle DEF. And then angle bisector, bisector just means cut into 2 equal pieces. So I could have a situation where this is a 20-degree angle, that is a 20-degree angle. This is cut into 2 congruent angles. And this line in the middle is your angle bisector. So you may want to pause for a minute and make sure you have all these pictures down. And we will do a few more geometry basics vocabulary words as well. All right, another situation that we run into is called the angle addition postulate. So what this basically means here is, let's say that I have 2 angles. So let's say that I have a 30-degree angle and a 35-degree angle. I'll call this A, B, C, and D. So what I could say is that the measure of angle ABC plus the measure of angle CBD equals to the total of the 2 angles. So I'll maybe make that in lime green. So 30 plus 35 is 65 degrees. So that would be the measure of angle ABD. And that is 65 degrees. And we get that by just adding 30 and 35 degrees. And then the last one that we have here are perpendicular lines. So anytime we have the mentioning of a perpendicular, that creates a 90-degree angle. And if you see this symbol in your proofs today or this week, this means perpendicular to. All right. So those are some common building blocks that you're going to see in proofs. And we can use these things to create like congruent angles and stuff like that. So now we're going to shift gears and go to some situations that create parallel lines. So I wrote kind of the terms and conditions of these angles and what has to happen for these lines to be parallel, to create parallel lines. So like an alternate interior angle, let's say that I have 70 and 70. So these are alternate interior angles. I could have a situation where I have angles that are on the opposite sides of the transversal, and are on the exterior, maybe that angle is 110 and that angle is 110. The same side interior, we see these a lot in like, parallelograms and stuff like that. So maybe if this angle is 70 and 110 and they add to 180, that means that our lines are parallel. So like where we may kind of see the alternate interior in triangles, I just kind of draw another example. So if we have a situation like that, that is a alternate interior and parallel symbol on a diagram. This means parallel to. Alternate exteriors. You could have, situations like that. And then the same side interiors, this is where we could actually get things like that. And maybe my lines are marked parallel. And then the corresponding angles, this is when you have a situation where you have the same relative location. So actually, let's say that that's 110 and that's 110. And I just put what these angles are looking like. And we want corresponding angles to be congruent. So they need to be congruent. Other useful facts. One thing that we can use is that the three angles of a triangle are 180 degrees. So I could say ABC. I could say that the measure of angle A plus the measure of angle B plus the measure of angle C equals to 180. And I could say that the four angles of a quadrilateral add to 360. And then the base angles of an isosceles triangle, and I'm going to draw that line of symmetry, are congruent as well. And then we have some other important proof reasons. Obviously, we give you the givens. So those first statements, the reason will be generally given because we already provide some statements for you for free. And definition of congruence is when you are changing from congruent to equal sign or back again. So if I am going from the congruent symbol to the equal sign or the equal sign to congruent symbol, I'm using definition of congruence. The reflexive property is used when we have a shared side or angle. So maybe I have A, B, C, D, and I could actually say that AC is congruent to AC. And then the transitive property combines two statements to create a third statement. So for example, I could have a situation where I have congruent sides. Actually, we'll call this C and D and E and F. So if AB is congruent to CD, and CD is congruent to EF, then AB has to also be congruent to EF. All right, so the good news is these are most of the properties that are going to be used in your proofs. So the geometry basics, the properties of parallel lines, things like the 180-degree triangle theorem, and these common reasons. And if you know all of these vocab words, there's a pretty good chance that you're going to be passing geometry this semester. And there's also a pretty good chance that you will be able to master proofs. And I think it is a priority that you make sure that you have these vocab words down on a sheet of paper before trying any of the problems today on Delta Math and doing any of the proofs in the next few weeks. All right, let's look at some example problems. So this is finding angles without the justification. So it says in the diagram below, BC is congruent to EC. So I'm just going to mark BC. And I like just doing connected dots. And then I have EC as well, that is congruent. And it tells us that DCF is equal to 44 degrees, and they already have that marked in the picture. And they are asking us to find ABE. So I'm just going to get another color here, and I'm going to trace out ABE. So one thing I will say is that if you are trying to immediately solve for the angle that they are asking, you may find yourself stuck. However, there are angles that are much easier to find. So the first one that I would do is I would start at the 44, and I could see pretty quickly that the angle over here is 44. And I got that because these were vertical angles. And I also notice here that I have an isosceles triangle. And I can use the base angles theorem. So down here and down here, and this isosceles triangle is nice and symmetrical. And maybe I'll call this angle X and this angle X. So I could say that the triangle adds to 180. So I could say that 44 plus X equals to 180. So 44 plus 2X equals 180. And I'm going to subtract 44 on both sides. That's 136. I'm going to divide by 2. So therefore, X is equal to 136 divided by 2. And that is going to be 68. And then I could say that this last part here, I have a linear pair. And I'm going to add X plus Y. I'll call this angle Y, just to kind of have like a variable, is 180. So I have 68 plus Y equals 180. And I'm going to do 180 minus 68 to get a total of 118. So what went on here? But what we did is we started with the easiest to recognize. And it's always good to kind of start at the angle that they give you and then work your way towards where you want to go. Now, what I did is that every time I saw a vocab word, I actually put that vocab word on the diagram. And when you're doing that, you're actually giving yourself reasons that are not only going to help you solidify your vocabulary for solving a problem like this, but when we do get to like proof level type of tasks, you're going to be better able to recognize what your reasons are. So let's try another one. All right, so example 2 here is finding angles. So this says in the diagram below, AB, B is kind of disappeared from my screenshot here, is perpendicular to, so that's what that means, perpendicular to AD, and DE is perpendicular to DC. So they already marked in those right angles, and they also marked in the congruent angles as well. And ACB is equal to 60 degrees. Find the measure of angle BCE. So this triangle I know a little bit more about because I have 2 out of the 3 angles. So I'm going to call this angle X, or we could just say the measure of angle B. So I could say that the measure of angle A plus the measure of angle B plus the measure of angle C equals to 180. And I'm just going to do 60 plus X plus 90 equals 180. And that combines to 150. Subtract 150 on both sides for a total X of 30. I'm just going to put 30 right there. And since I know that angle B is 30, the angle that is marked the same also needs to be 30. And they are asking us for the measure of angle BCE. And I will just outline what that angle is going to be that we need to find. So BCE. I also know that when 3 angles kind of come together to form a line, that these add to 180. So I could say that 30 plus measure of angle BCE plus 60 equals 180. And therefore, measure of angle BCE is equal to 90 degrees. Because we should all 3 add to 180. All right, we're going to do one with justification as well. And if you have been, even on these problems, just recording the reasoning on the sides, the justification will actually not be too much harder. All right, this last one we will call example 3. And this is actually going to show you the features of justification. And what we're just doing here is we're putting concrete reasons for why we are going from one step to the next. They are actually literally the same problem as the first 2, except now we're just putting our reasons in them. And we're just going to look at the information that is provided. So this says in the diagram below, AD is parallel to EG. So I'm actually just going to mark the diagram for that. And BFC is 73, FBC is 40, and we need to find GFC. So I'm just going to highlight the angle that we need in green, GFC. All right, so there's a few ways that we could go. I think that the easiest route to go is to actually find first the third angle in the triangle. So I would actually just go and find that third angle. So I would say 73 plus 40 plus x equals 180. So this is the triangle sum theorem. And let's see, 73 plus 40 is 113 plus x equals 180. And we will get 67 degrees as a result. And the name of that angle is FCB. So I have FCB equals to 67. And I already thought of the name of the reason. I said it was the triangle sum. And the sum of angles in the triangle pretty much describes that situation. So we try it out. And it's a beautiful thing. All right. So there's a few ways we could go. My suggestion here would be to look at the fact that we have a parallel line and we have sort of a zigzag of sorts. So this angle and the green angle kind of have like a zigzag effect. And both of them are inside of the parallel lines. So I noticed that we have alternate interior angles. So I could say then that GFC, which is the angle that they want us to find, also is 67 degrees, because angle FCB and GFC are alternate interior angles. And because I already was thinking about that, I can actually go and select a reason. And I'm going to look for alternate interior angles. And there we have it. And now that I have figured it out, I have figured out the angle that we need. And it will just tell you to submit so that you can get that green check mark. So, moral of the story on these problems: make sure you know what the symbols are asking for. Don't be afraid to use like a highlighter. Think about the vocab word. So think about your cheat sheet. Do you see a vocab word on your cheat sheet to help you find some angles? And I think it's always good to look for the easiest angles to find first. So the more angles that you can find, the better, and the closer you'll get to the answer.